It's another math day here with teacher Jenny. Join me for another topic, and this time we're going to talk about continuity of a function at an interval for rational function. Let us try to determine if the function is continuous at the given interval for f of x equal to 5 over x squared minus 1 from the interval, close interval -1 and 1. So first thing, this is rational function. And for rational function, we don't want our denominator here to be equal to a 0 because this would lead to an undefined answer or result. So once you've got undefined result, automatic the function becomes discontinuous at that particular value of your x. So we avoid that one. Now, to know what makes our entire denominator 0, we will have to bring the denominator out, x squared minus 1. Then we try to equate that one to 0 because we wanted to know what is the value of x that will make our entire expression there equal to 0. So let's try to solve for x. We move 1, -1 to the other side by simply adding here, because this is a -1. Once we add 1 here and also here, we will be removing our -1 from the other side. Here in our place, we call this one as transposing. We try to transfer the -1 to the other side. Once you transfer that one, it will become or it will change the sign there. So automatic from -1, that will become a +1 on the other side. So this is now x squared equal to +1. And then we try to get the value of x by getting the square root from your x squared. So getting the square root of x squared, we cancel the square root symbol, and so with the square, we are left with an x. This is equal to a positive -1 because that is square root of 1. The root of 1 is going to be either +1 or -1. So there are two values of x that will make the entire denominator equal to 0. You may go ahead and try to replace your x there in the denominator, and you would see that that will become a 0, which will make our function undefined. So we avoid those things. So that means our x must not be equal to a +1 nor a -1. So if you try to look at our interval, satisfying our conditions here for the continuity of the function in an interval, we have to check on the first thing. We have to check if f is continuous or the function is continuous at the interval, the open interval AB, wherein our a here is -1, our b is 1. now go for the next example. We have f of x equal to x over x plus 3. So again, we are going to get the denominator x plus 3, equate that one to 0, and know what the value of x that will make the entire denominator equal to 0. Our x value here is a negative 3. And upon checking, although we need to follow the condition there that f is continuous on an open interval, which is negative 3, 0. If you try to check on that one, you would notice that our x there is continuous in nature because negative 3 is not part of it. So this will make it satisfied. Now, next thing is, this is a problematic one because our b here, we are trying to test out whether our limit of f of x as x approaches our a coming from the right side will be equal to our f of a. So checking up, we have our limit of f of x is x over x plus 3. Our x approaches negative 3 coming from the right side. Will that be equal to f of negative 3? So let me just try to check on f of negative 3 first, because if you try to recall testing out the continuity of a function at a particular number, we do start with checking whether f of negative 3 is existing. So we have f of negative 3, we have over x, I mean equal to x over x plus 3. Then we try to replace x with negative 3. And then we try to simplify this as negative 3 over a 0. From this on, this is already a DNE. It does not exist at all. Your point there where x is negative 3, it's not existing. So automatic, this is not continuous under this interval. So again, this is discontinuous at negative 3, 0. So that is how you are going to check on the continuity of a rational function with a given interval. So once again, this is your teacher Jenny saying, practice and practice, and that makes you perfect one day.